In the past, in my channel, I posted several videos about how to achieve DNS privacy and security. In this video, let's talk about Ubiquiti UniFi. Without using any built-in router features, in fact, you can already achieve the DNS encryption inside your local network by using something like dnscrypt-proxy. It's a proxy that supports popular encrypted DNS protocols, for example, dnscrypt, DOH, and ODOH. But if you use UniFi routers, you have a much easier way to implement DNS encryption using the so-called DNS Shield feature without all the troubles of configuring dnscrypt-proxy all by yourself. So in this video, let's understand how the DNS Shield functionality works inside the router, and we can compare the pre and the post situations when it comes to DNS queries. We will go to the router backend to see how the system works before you enable the DNS Shield. We will test it using Wireshark in both LAN and WAN to see the DNS queries. Then we will enable DNS Shield to see how the backend configurations are changed. We will run 3 parallel packet capturings so that we can see in LAN, WAN, and inside the router how the DNS queries are supported. In the end, we will discuss a special situation. What if you enabled DNS Shield and you configure the DNS server in DHCP to a totally different server? So whether the DNS Shield still works. As you can see in the UniFi network controller, at this moment, the DNS Shield is disabled. So let me go to network settings. I have multiple VLANs configured, plus I have 2 layer 3 switch VLANs. That's why you also see the 4040 special VLAN to support the layer 3 switch. Go to the internet setting. If I go to the advanced setting for DNS server, let me change it from author to 8888 for Google Public DNS Resolver. Apply changes. Then in the lower part, if I go to a random VLAN, for example VLAN 10, under the DHCP setting for DNS server, you can see it's author. Author means the client will use the router as the DNS server. I assume there must be something running inside the router, and the process is listening on port 53, which is for DNS, right? So let's validate it. I'm running the Linux netstat command to list all the processes which are doing some network traffics. I'm only interested in the port 53. A lot of things are happening for both IPv4 and IPv6. Let's just use IPv4 UDP as example. As you can see, the same command, dnsmasq, is listening in different subnets. I can see this is for default VLAN, this is for VLAN 10, this is a hard-coded IP address, and it is for the special VLAN 4040 to support layer 3 switch routing. I see multiple internal DNS servers already. Interestingly, you can see another one which is for the local host for the LO interface. And then if I run another command, you can see how dnsmasq command is run to support these DNS services. As you can see, the configuration file is inside this folder. Let's go to this folder to find out the configuration files for dnsmasq. Let's see what's inside. So we see 4 configuration files for DHCP. They are not relevant to this video. We are interested in this configuration file, which is for DNS. So let me see what's in the configuration file. It's pretty straightforward. It's listening on all these interfaces for different VLANs and the default network, the BR0 bridge. If I go to another folder and run dns.config.d, I can find this file. So this is the configuration file used by the router to know what's the external DNS resolver it should use. Let's display it. We only see one name server. Why we see this one? Because in UniFi Network Controller, we configured the primary DNS server to this one, right? So now, as shown in the diagram, we see dnsmasq is supporting different VLANs for DNS name resolving, but internally, they are all using the same configuration file to use external Google's name server. So let's see in this situation where DNS Shield is disabled, what the potential problems may be. As shown in the diagram, I'm going to run two parallel Wireshark sessions, one monitoring the VLAN 10 traffic, the other one will monitor the one part traffic. Launch the two Wiresharks, start capturing. As you can see, for both sessions, I already filtered the displayed packets using DNS. In the one part, the first Wireshark, you already see a whole bunch of DNS packets captured, but they are sent by the router for the connectivity and the latency testing. They are not relevant to this video. From the VLAN 10 Wireshark, you can see nothing's captured, right? And to make it more interesting, in the SSH session, let me run the TCP dump in the UniFi router. Here I say for any interfaces, as long as the port is 53, I want to see the packets. Let me run it. It's in sync with the one part capturing. Now let's do our own testing. In the terminal for VLAN 10, let me run digx.com. Okay, got the result back and stop capturing in the router and on the one part and for the VLAN 10 as well. Let's examine the captured packets to see what happened. In the dig command result, you can see it got the result back from this IP address, which is the IP address for the VLAN 10 for the router. And then it got 4 IP addresses for the same domain name x.com. If you check the captured packets, you can see this Linux client directly send the query to the UniFi router. And then UniFi router replied. So the client only communicated with the router. That's it. If you see from the WAN perspective, this IP address .2.123, it is the UniFi router's WAN part. Because I'm running the lab environment behind my home network's main router, so that's why you see the IP address, which is also a private IP address. So the router asks Google, and Google reply back to router. And from WAN perspective, the two packets have nothing to do with the Linux client from VLAN 10. Right? That's also expected. And then let's check the TCP dump inside the router. Starting from this one, the Linux machine asks the router, and then the router asks Google. Later, the Google replied back to the router. Then the router replied back to the Linux machine. So basically, the dnsmasq running in the VLAN 10 is relaying the packets, helping the clients to get the domain name resolved. So far, nothing's really interesting. Everything's expected. But there are some potential security concerns. So first, from the LAN perspective, see the protocol is DNS. I simply run a Wireshark and I know what the domain name the client is trying to resolve. And from the WAN perspective, again, the protocol is DNS. It's not encrypted. So anyone, if they want, they can know what DNS queries came out from your router. The LAN part, the VLAN 10 thing, maybe it's not a big deal at all. Anyway, it happens in your home network. In most cases, even if it's not encrypted, it doesn't really matter, right? But the WAN part may really concern many people because it's a potential privacy problem, potential security problem. Of course, to resolve it, there are a lot of different ways. In this video, let's talk about Ubiquiti's approach, the so-called DNS Shield. Before enabling DNS Shield, I need to go to the network controller. For internet, let me revert back the DNS changes I made in previous scenario. If you don't enable DNS Shield, if the internet DNS server setting is altered, it means it will use the default DNS server provided by your ISP. Now I can go to the security setting. You can see there are two ways to enable DNS Shield, alter and manual. Let's try the easiest one first, alter. Then you can see these two, Cloudflare and Google, are selected by default, but they are grayed out. You cannot change it. That's what alter means here. Apply changes. From a client, for example, this Linux VLAN 10 client, let me dig x.com. This time, from the client perspective, the same thing happened. So the reply is still from the UniFi router. To understand whether in backend anything's changed, we need to go to the system configurations. So in the left side, let me cd to this dnsmasq configuration folder. Remember last time we did display this configuration file but didn't find anything interesting, right? So this time, let me do it again. See the very last line. This is brand new. After we enable the DNS Shield, dnsmasq will forward the DNS query to another DNS resolver. Because this is new and the port number is 5053. So to understand what happens for the port 5053 and 53, let me run this command to see the processes which are listening on this part or this part. Okay, this time we got two new lines, one for TCP, one for UDP, both for the port 5053. And if you check the process name, dnscrypt-proxy, the one I briefly showed you in the beginning of the video. Okay, so now we know what's the new DNS resolver in the backend, but we want to know what it is really doing. So to understand that, let me run this command to list all the processes, but I'm only interested in the command line for dnscrypt-proxy. So now we get the configuration file. It's this one. Let's display it. Okay, a lot of things are going on. Let's go through them. The first line, it indicates the IP address and port name, the same information we already saw in the dnsmasq configuration, right? And then the second line, server names, Cloudflare and Google, they match the exact same information, the same sequence as we set in the DNS Shield in UniFi network controller. The next one is also important. Remember in the beginning when we talked about dnscrypt-proxy, we said it supports multiple DNS encryption protocols, but here it only says, okay, we support DOH. When you enable DNS Shield in the backend, the dnscrypt-proxy will use DOH to communicate with upstream DNS server. Then another important section is called sources. In the beginning, we say, okay, we want these two servers. But what are these two servers at all, right? So they are specified in the sources. Here it mentioned two URLs for the same file. To understand what is configured in the public resolvers file, let me launch a separate browser. In the public resolvers file, it lists the public DNS resolvers that support the dnscrypt and DOH. If I search Cloudflare, for example, the comment Cloudflare. By using this, DNS Shield can find the configuration for Cloudflare, and the detailed configuration is all embedded in this strange long string. This is called a stamp. In dnscrypt-proxy configuration instruction file, it explains this stamp encodes all the required parameters, such as the IP address, the name, protocol, and keys. By using this string, dnscrypt-proxy can connect to the upstream DNS server, which supports DOH. To see the DNS Shield works in action, let's repeat the similar exercise we did previously to capture the network frames in WAN, LAN, and inside the router. Start the Wireshark on the WAN part and for VLAN 10. By the way, similarly to previous scenario, now even I haven't done anything in the VLAN 10 client yet, you already see a whole bunch of DNS packets from the one part. That's expected because the router has been doing the frequent connectivity and the latency testing. Now in the SSH session into the router, let me run this TCP dump command. This is a little bit more complex than previous scenario. The reason is this time I want to listen to the part 5053. It is not the typical 53 DNS part. So TCP dump will not interpret the content, then dump the information on the screen. So to easily understand what's going on, I want to capture it to a file. But at the same time, I also want to display the captured information on the screen. So this is what I'm running. Okay, start it. Now we are ready. So from the VLAN 10 Linux command, let me dig x.com. Now there's something strange, right? So from client perspective, yes, I see the back and forth. But from the router for the TCP dump, when I did the DNS query, nothing's captured. What you are seeing now, they are not relevant to our testing. Something strange, nothing's happened in the dnscrypt-proxy. Why is that? You may know every DNS resolver, they have their own local cache. Because I have been frequently testing x.com, apparently the DNS result has already been cached somewhere. That's why the system didn't bother querying the result again. So to force the DNS query to happen, let me do this. First kill the current capturing. Then let me kill the dnsmasq and restart it. Okay, done. Then let me run the TCP dump command one more time. Okay, start it. Do the same thing in the Linux client. Okay, see the TCP dump captured something, right? Stop it. And then in the client, stop it. In the one, stop it. So let's start from the easiest one, the VLAN 10 client. So start from the third packet because that's our second test, right? The Linux client send the DNS query to the router, which is the dnsmasq. And then the router replied, nothing special, nothing's interesting, nothing's changed. Okay, then let's check the one part captured packet. Among all the captured frames, I cannot find anything which is related to x.com. But we know there must be something happened because we see the traffic in the router, right? So then why is that? Remember, after we enabled DNS Shield, the real DNS query to outside external DNS server will be done through DOH, which is encrypted. So that's why the protocol is not DNS anymore. So let me change the DNS. Instead, let me use TLS. Okay, now you see a whole bunch of packet. In the very end, somewhere we should find our packet. Yes, so see the 1.0.0.1. Why we have this strange IP address? Remember in the public resolver file where the Cloudflare is configured, here, see, it has two different IP addresses. Apparently this time it's using the 1001 IP address. Okay, so the router .2.123 ask the Cloudflare server using DOH, and then the Cloudflare server replied. And because it's encrypted, I have no way to see the content. I won't be able to tell what the domain name is being requested. That's exactly the purpose of DOH. You already see the end result of DNS Shield. It is encrypted, so your traffic in the one part is secured. And then to furtherly understand what happened inside the router, remember we have the TCP dump captured something and we saved to a local file, right? Let me use this Linux client to run the scp command to retrieve the captured file from the router to this local Linux machine. Okay, done. Then let me use Wireshark to open the captured file. two simple frames captured, and the protocol is DNS. It's simply from the source, the local host. The destination is the same local host, but the port number should be different. Let's find it out. See, the destination port is 5053, right? Which is the dnscrypt-proxy. dnsmasq ask dnscrypt-proxy was x.com. And then from the one part, you already see the dnscrypt-proxy ask Cloudflare, and then Cloudflare replied. Then the dnscrypt-proxy replied back to dnsmasq. Then dnsmasq replied back to the Linux machine. That's how the DNS query was done. And you can also notice the protocol is DNS, so inside the router, the traffic is not encrypted because it's not really necessary. Before we move on, let's revisit the DNS thing. Let me change the filter back to DNS in the one Wireshark. So someone may ask, we already enabled DNS Shield. Why there are still so many non-encrypted plain DNS queries going out of the router? Why they don't go through the DNS Shield? This is something related to how the router finished the latency checking, the connectivity checking, and how the router itself, how it resolved the DNS name. We already covered the topic in another video. If you are interested, you may want to watch that one. Let's move on. We just saw the effect if we enable DNS Shield and choose Alter, right? What if we choose Menu? You see these two selected items, they are enabled. You can delete them. Then if you click on the Select, you will see a long list of servers. You may wonder where they come from. Remember in the SSH session, when we checked the dnscrypt-proxy configuration file, we see the public resolver files, right? Yes, the list in UniFi Network Controller is exactly from the same file. Okay, so we know where they come from. But you may wonder, does it make any difference if I choose a different one? Because anyway, Google or Cloudflare, they are well known, they are reliable, right? So what's the difference if you choose other ones? Ubiquiti hasn't done a great job explaining what this list of servers for, but I believe there's a reason behind it. Because on one hand, Ubiquiti wants to give you the illusion that DNS Shield is a fancy thing, but on the other hand, now we know it's simply using dnscrypt-proxy, right? So Ubiquiti has a difficult situation to explain where the list is for. But you can even tell from the simple name what they are for. For example, the add filter, yeah, it's to filter out S, right? But what's the real difference? You have to go to the file to read the comments, do your search by yourself. But here in this video, let me just do a simple testing. Let's say for the very first one, just from the name, it suggests it's for add filter, right? So now I haven't changed it yet. So my current DNS Shield is still using Cloudflare and Google, right? In the VLAN 10 Linux client, let me dig a domain name, adservice.google.com. I know this one is normally blocked by ad blocker, but let's see if we are using the plain Google or Cloudflare, whether I can get the IP address for it. Let me do it. Yes, I can. No problem, right? So now in the network controller, let me pick the very first one just as an example. Save it. So see, I only have this one selected. Apply changes. Okay, it should be effective now. Let me go to the Linux client, dig the same domain name again. First, it took longer time. Second, it got or 0 IP address, even though the answers, the count is 1, which means the DNS query itself was successful, but you don't get the correct IP address back. Why? Because we used this add filter public DNS resolver as our DOH server. Okay, so just a short demo to explain, yes, the server matters, but you are on yourself to decide which one to use. As the very last part of this video, let's discuss a very special situation. So what if you enabled DNS Shield, but in your VLAN's DHCP's DNS server setting, you point to a different DNS server? How the DNS client will react? For example, here in the UniFi network controller, under security for DNS Shield, let me change it back to Author, which means it will use Cloudflare and Google. Then let me go to network for VLAN 10, go to the DHCP setting for DNS server. Let me change it to a different one, let's say 9999. Okay, apply changes. Then in the Linux client, let me refresh the DHCP by disconnecting and then reconnecting again. Okay, now the DHCP should be refreshed. digx.com again. Okay, got the result back. See, it got the result from 9999 instead of Google or Cloudflare. So that means if you change the DHCP setting, it will still apply and it will still take priority over the DNS Shield setting. That's expected. But what if we change the internet DNS setting? That should be an interesting testing. Before doing that, let me change back the VLAN 10's DHCP, change back to Author. Then from the client, let me disconnect, reconnect. Okay, DHCP refreshed. So now the DNS Shield is still enabled. What if for the internet DNS server setting, we change it to 9999? Okay, change is effective. Restart the capturing on WAN and LAN again. This time, let me digx.com one more time. Okay, stop capturing. So from dig command, the result is expected. The server is the router and it got result back. And from the WAN part, if we check the DNS packet, I don't see 9999. And if we check the TLS packet, yeah, I do see the 1001 IP address, which is for the Cloudflare, right? So which means after enabling DNS Shield, the internet DNS server setting won't be effective anymore. It won't be used. The system will always use the DNS Shield approach. Okay? So let me repeat. If you change the DHCP DNS server setting for your VLAN, it will still be effective even if you already enabled DNS Shield. But the internet DNS server setting won't be effective if you have the DNS Shield enabled. Okay? This ends this a little bit long video. Thanks for watching.